We'll get started now. I think everybody can hear me. I have to laugh a little bit. Some of you are like, you adults in the back are like the students in our classes. We wanted you up close to us, but anyway, hopefully you won't need to make a break for it or not. You'll be fascinated for the next 2 hours. Very privileged to have our friends from Toledo Excel with us this morning. We know you do have to leave in a bit, so when they leave, it's not out of anything they're unhappy with, and they're not just going to get some donuts then in the next room, or maybe they are. So a couple things. My name is Mike Toole, and I have the honor of serving as the Dean of the College of Engineering here at University of Toledo. A couple infrastructure, logistics things. First of all, for those of you who couldn't join us for breakfast before, we have tons of donuts and muffins and more sugar per square foot than I've seen in a long time. So you can hit something and maybe even some coffee and water after this ends at 11. The other logistical thing is, let's silence our cell phones, of course. And then finally, we're going to have a great panelist today, some speakers and then panelists, and you'll be able to give questions to the panelists. So if you'd like one of these blue index cards, just raise your hand now. If you think you might want to ask a question, raise your hand now. Diana Van Winkle, who deserves so much credit for all this, will give you some cards. So she'll be walking around. If you see Diana, just stick your hand up. She'll give you both a pen and a card. Okay, thank you. So it's my pleasure to welcome you all today, again, especially our friends from Toledo Excel, to this third in a series of seminars at the college that will focus on autonomous vehicles. What began as a conversation about possibilities to provide an educational platform for autonomous vehicle technology has evolved into something much more. When AAA partnered with the University of Toledo's College of Engineering to explore ideas on important related technology topics, our speaker series was born. And what a partner AAA has turned out to be. We've been inspired and aided by their commitment to innovation in our infrastructure and their commitment to improvement the quality of life in Toledo and our nation overall, and by their strong relationships with industry and government. So I know that many of you attended the February kickoff seminar, which gave us an overview of the topic of autonomous vehicles. In April, we discussed the importance of cybersecurity in relation to autonomous vehicles and focused on a set of technologies and systems that are clearly some of the most exciting and potentially disruptive innovations facing our society today. This morning, we'll be focusing on public transportation and autonomous vehicles. We'll be hearing about the future of not only transportation vehicles, but how our cities will need to change to accommodate this change in our infrastructure. And that will lead us to our September seminar. We'll be focusing on infrastructure, government regulation, and autonomous vehicles. As our roads and cities change, engineers will be needed to make these changes. In November, we'll be addressing one of the most exciting subjects in this topic, accessibility and autonomous vehicles. So I'm a civil engineer, and so it makes me very happy to talk about autonomous buses this morning. We know that public transportation is a critical part of our nation's infrastructure. While the name AAA, the automobile in it, suggests that AAA emphasizes the importance of automobiles, they have a much bigger picture, and so do we. We all know that our fellow citizens, not all of them, cannot afford to own an individual automobile. They sometimes can't even afford a ride-sharing service like Uber. And so autonomous buses need to be part of our path forward for creating innovative and efficient public transportation systems. So we join now with our partners in this series, AAA of Northwest Ohio, in celebrating the achievements of fellow engineers and scientists in creating the technologies that I'm confident will prove significantly to reduce traffic deaths around the globe and provide mobility to millions who would not otherwise have it. Thank you for joining us here today. So now I'm very pleased to introduce our MC for today's event, Ms. Lisa Guyton from 13 ABC News. Lisa has been a television anchor and reporter for nearly 30 years. She spent the last 15 years working at 13 ABC. Lisa grew up in Perrysburg and graduated from Maumee Valley Country Day School. She has a degree in communications from Stevens College in Missouri and is grateful to be doing what she loves in her hometown. She's been covering the auto beat for more than a decade. A lot of recent coverage is focused on self-driving vehicles. She also reports on many animal, business, and human interest stories for the station. She describes herself as fiercely loyal to our city, and she's proud to be involved with events like Technology Takes the Wheel. She volunteers her time for a number of charitable organizations in the community. Much of her spare time is spent with Real Horsepower. She's an avid equestrian who began riding horses at the age of 4. Please join me in welcoming Lisa.
Well, good morning, everyone, and thank you so much for being here with us. This has been a fascinating series to be part of. As he mentioned, this is the third event in this series, and I've learned so much from all of these. As he said, I've been covering the auto beat for probably the last 10, maybe even close to 15 years now, and it is truly incredible how much of a shift we have seen in that industry, the technology changes and leading us right up to these autonomous vehicles. So what an important time to be a part of all of this. So it is a true privilege for me to be able to share stories like this with our community, and for that I am grateful. But it's an exciting time. We are really on the edge, the cusp of some incredible new developments within the industry, and we are certainly positioned well in this fabulous city of ours to be an important part of it moving forward. So I'm proud to be able to share these stories with our viewers, because we are really positioned, as I said, to be part of that huge shift that's going to be right around the bend here as we move forward. So thank you so much for being with us again today. These are really critical events to host in the community, because you have a chance to learn so much. You really have a chance to get the inside scoop before everyone else does. So thank you for joining us this morning, and I want to remind all of you, a lot of you just got those cards. Please make sure to write any questions on those index cards. I see very well. I'm past the age where you're supposed to have glasses, but please write as clearly in large print as you can, so that we can make sure that I'm asking the correct question for you. And then you just hand them to the helpers who are walking around at the end to collect them, so that we can ask those questions during the panel discussion. Now, the first speaker in our lineup today is Mr. Chris Pauley. Chris is the Director of Business Development for North America at Navia, a manufacturer of fully autonomous, fully electric 15-passenger shuttles and 6-passenger taxi cabs. Previously, Chris worked as a business development manager for Underwriters Laboratories. He graduated from the University of Iowa with a BA, DePaul University College of Law with a JD, and Northwestern University Kellogg School of Management with an MBA. Please join me in welcoming Chris Pauley.
Thank you, Lisa. First, before I get started, I wanted to thank the University of Toledo and as College of Engineering, as well as AAA Northwest Ohio. Without your support, obviously, we wouldn't be here, so thank you so much. A little bit about Navia, a little bit about myself. As Lisa mentioned, my name is Chris Pauley, Director of Business Development for Navia. Navia is a French-based company. We have dual headquartered in Lyon and Paris, France. As of last year, we actually opened up our first manufacturing facility in Saline, Michigan. We're outside. You can see and visit our first U.S.-produced autonomous shuttle. So if you haven't had a chance, please go outside and take a look, jump on. So part of the reason why Navia was formed was to look at some of the large macro trends approaching cities in the future. So by 2050, some 70% of the world population will be concentrated in cities. And so that's going to lead to increased congestion, traffic issues, as well as parking and pollution issues. And so from our standpoint, autonomous vehicle technology then leads to really three areas of technology innovation and evolution. That's through increased transportation network efficiencies, through improved service, and the creation of new service models. And so as you think about autonomous vehicles today and in the future, you'll look at this through more of a transformation lens, similar to the mobile phone industry, where you had the initial phones being created, and then what we have today has been pretty much a revolution of technology changes. So a little bit about our company. Our mission really is to supply and support the advent and distribution of autonomous vehicles throughout the world, whether it's in cities or campus-like environments, like here at the University of Toledo. Our mission really is to put out and adopt the driverless, fully autonomous vehicles. A little bit of statistics about us, as I mentioned before. We went ahead and launched our shuttle back in 2015. Last November, we actually launched and announced the creation of a new 6-passenger taxi cab. Again, we're dual headquartered in France and the US, and then we transported something over 200,000 passengers worldwide. little bit of view in terms of our shuttle. So both of our vehicles operate on what's considered level 4 or level 5 definition of automation. And that just means that in many respects, you don't really need to have anyone operating the vehicles. Real quick, 15 passengers, as was mentioned before. Speeds up to about 28 miles an hour, although you won't see it drive that fast when you're operating in a campus-like environment. We're usually putting around between 10 to 15 miles an hour. So a little bit about the technology. So our vehicles have what we call multi-layered technology pieces on the vehicle, whether it's a GPS-like system called GNSS, which allows our vehicle to triangulate up to 17 satellites in the world. It actually gives our engineers the impression of within 1 inch or 1 centimeter of distance from the route, so it's very accurate. We also have a LiDAR system, which is a light-based radar system on the vehicle that surrounds the vehicle at all times and goes ahead and perceives not only what the road bed's supposed to be looking like, but also any other, whether it's bicyclers or pedestrians or other light vehicle traffic coming towards the vehicle, gives the ability for that vehicle to slow down or come to a stop. We also have some camera systems based in the vehicle as well. And all those systems integrate and work together to allow for the vehicle to operate safely. So just some examples of where we think this type of technology is going to be used. So obviously in cities, we are in Las Vegas. We've been operating since November of last year. We are at the University of Michigan's campus, hopefully at the University of Toledo's campus at some point in time in the future. But also airports, theme parks, hospitals, really what we look at from what we call a first and last mile perspective. So transporting folks from one point to the other, typically within a 2.5 mile loop. And this is more of a visual depiction in terms of where we are around the world. As you can see in the US, we have 4 spots. We're heavily concentrated in Europe since we are a French-based company, and then we do have shuttles that are deployed right now in Southeast Asia, Australia, and Japan. So this is just a quick little video to show the shuttle in action. So along with the shuttle itself, we also have a service which allows for us to have real-time management of these shuttles. And so something called our Navia Lead or Navia Supervision Service allows us to track the vehicles at all times, and we're able to monitor them for things such as state of life of the battery, any other diagnostic systems, along from a safety standpoint as well. So if the shuttle is having an incident, there's someone that's had a health issue, the passengers on board the vehicle are able to hit a button. We're able to have remote access into the vehicle, to peer into the vehicle, to see what's going on, talk to the passengers as well. And so this is something that differentiates ourselves from existing technology that may be on the road today. And as I mentioned before, we went ahead and announced back in November the production of our first autonomous cab. And so this is a 6-passenger cab. The use case for this vehicle is slightly different. So for our shuttle, it's more of a 2.5 mile first and last mile type of use case. For the taxi cab, this is actually more for an intra usage within a city. So you can imagine going from one side of Toledo to the other within a 5-mile area, let's say. This vehicle can be used in an on-demand capability or on-demand service. It's more similar to a Uber-like or Lyft-like model. But again, obviously it's in a fully autonomous capability. Just some differentiation, of course. The similarities are autonomous, electric. Average battery length is about the same, but the difference really here is 1, it's smaller, and 2, the speed of the operation. So this vehicle can get up to where around 45 miles an hour, which obviously is a lot faster than our shuttle. Along with this vehicle, because of the speed, we actually have a lot more sensors inside of it. Obviously, with the faster vehicle, your room for error decreases. So therefore, we have more sensors, more systems on this vehicle than you'll see in our shuttle, which allows for the vehicle to sense and perceive things a lot faster and make corrective actions, slow down, or come to a complete stop if there is some sort of a hazard or issue in front of it. And again, from a technology standpoint, if you look at the 2 different slides here, you can see the perception that our vehicles have. It's really a 360-view perception. Not only are we monitoring what's ahead, we're also monitoring what's behind and to the sides. And so if you think about when you're driving and you're in areas traditionally where cars are operating, as a driver, you're looking in front, you're looking to your side, you're typically not looking behind. In that case, you can have a bicycle or you stop at a stop sign, somebody is approaching you. This technology is going to monitor and make a change potentially if there's some sort of an encumbrance or issue occurring. Once we are introducing our taxi cab, then you'll see, again, a much more Uber or Lyft-like experience with an app-based system where you'll be able to hail the cab will be able to come to your residence or, depending on the use case, could come to a transit station, pick you up and take you to a predispositioned area. You'll be able to actually have all your entertainment put into the vehicle as well. So once you get into the cab, you can stream your music if you want to. Within the cab itself, you'll be able to actually order tickets. You'll be able to have maps of the routes where you're going. And in the future, you'll actually be able to have tours done through the vehicle as well. So if you are going to tour downtown Toledo, you can have a tour inside the vehicle, and it could talk to you about the mud hens and everything else within the city of Toledo. So really, our whole point here is bringing automation for an autonomous vehicle to everyone. As we introduced back in November, now we have 2 vehicles. One is a cab and one is a shuttle. Thank you.
Our next speaker today is retired Lieutenant Colonel John Tucker. Now, Mr. Tucker joined Pathmaster, a traffic management company in the Cleveland-Akron area, in November 2017. As a sales specialist, he is focused on connected and autonomous vehicle technology and its integration with infrastructure to include vehicle-to-vehicle, vehicle-to-infrastructure, and vehicle-to-everything connectivity. He is responsible for providing traffic management solutions to municipal, city, county, and state organizations in order to enhance safety, improve mobility, and reduce the environmental impact of vehicles. Prior to working at Pathmaster, Mr. Tucker served for nearly 21 years in the United States Army as an attack helicopter pilot. He has a Bachelor of Science in Aerospace Engineering from the West Point and a Master's in Military Operational Art and Science from the United States Air Force's Air University. Please join me in welcoming Lieutenant Colonel Tucker.
Good morning, ladies and gentlemen. Chris said he wasn't going to play with this, so I will move that microphone up a little bit. I want to echo Chris's sentiments and thank the University of Toledo, specifically the College of Engineering, as well as AAA, not to be confused with Quad A, being a former Army aviator, for inviting Pathmaster to be part of this seminar. As you'll see in a few slides, we take it upon ourselves to inject and be an advocate for connected vehicle technologies. This is what I'm going to cover today. Is a short introduction, go over some connected and automated vehicles and connected infrastructure, define some of these crazy acronyms that you keep hearing, V to V, V to I, V to X, BSM, SPAT, all those things. Talk about a little bit of V2I, V2V, V to X, what exactly are they? Also, the focus of this is going to be vehicle to infrastructure, and this is a great segue from what Chris was talking about, whereas he focused on the vehicle or the shuttle or those cabs, whereas I'm going to be discussing the infrastructure. What defines a connected intersection? Some of the benefits, a lot of which were already hit on. Some challenges. There are absolutely some unique challenges as we deploy this connected vehicle technology. And lastly, a conclusion on what you can do now to prepare for the future. Because like it or not, connected and automated vehicles and connected infrastructure are coming. So, Pathmaster is a traffic management company located in Twinsburg, Ohio, which is outside the Cleveland, Akron area. We've been in the traffic management business for over 40 years, and all along the way, we have seen technological advancements for the better. We have a firm belief in inventory, value, and service, which is nested nicely with both the University of Toledo as well as AAA. Our owner has a relentless pursuit to remain an industry leader, hence our involvement in all this CV technology. You can see a myriad of different universities, coalitions, etc., that we're involved with. Here at University of Toledo, we're working on a partnership and collaboration opportunity to include research and investment in the future of our traffic engineers, just as we do at the University of Dayton and also the Ohio State University. As I mentioned, AAA, we're very fortunate to be working with their organization as well, whose values integrity, conflict management, and again, service, their service. And especially here in Ohio, where they add an additional core value of teamwork. So we are proud to be part of the team between AAA and the University of Toledo. Traffic 21, you'll see that in the center there. They are an offshoot of Carnegie Mellon out of Pittsburgh, and they developed an advanced transportation management system called SureTrack and developed an entire business industry, which is a competitor of ours, Rapid Flow Technologies, but at the same time, they're an advocate, just like we are, for connected vehicle technology. We work hand in hand with them. Automated Vehicle Coalition, again, that's a coalition in Pennsylvania whose number one principle is to ensure safety of travelers. Safety of travelers is a primary driver of technological innovation. So you can see how all of these core values, these principles, et cetera, are nested nicely together with each other, between the university, between AAA, the coalitions, ourselves. Transportation Research Center, there's a big push down in central Ohio, of course. Governor Kasich signed an executive order back in January establishing Drive Ohio, and all that is surrounded or centered down in the Columbus area. It all starts at the Transportation Research Center, which is part of the Smart Mobility Corridor, connected Marysville, and ultimately Smart Columbus. And lastly, one thing that I want to address that's not on here are the MPOs. We work very closely with metropolitan planning organizations to ensure that they are taking the right steps for their communities in the advancement of these technologies. And in fact, Pathmaster is here today because of TMACOG's Transportation Summit back in March. And I think I saw Dave walk in. So thank you for that. We're absolutely proud to be here. All right, some of the acronyms, and I'm not going to go through all of these. I'll let you read some of them. CAV/I. You'll hear connected and automated or autonomous. A lot of times automated and autonomous are used synonymously within that acronym. Vehicles and infrastructure. You can see V to I, V to V, V to X. We hit on all those already. RSU is a roadside unit, which I'll get into shortly, as is an OBU. That is a DSRC radio that's installed in the vehicle. DSRC is dedicated short-range communications. That's a 5.9 gigahertz radio. That line right there is a designate or a line between messages and the other acronyms. So some of those messages you see below are all part of the Society of Automotive Engineers, J2735, current version 2016. So that's standards within the automotive industry. So the first one, SPAT, is signal, phase, and timing message. That is one of the biggest things driving all of this. Vehicles talking to the infrastructure, infrastructure talking to the vehicles. Hand in hand with that is map data. You know, the vehicles need to know what that intersection looks like. GPS correction, I won't go into that, but if somebody really needs to know, you get with me later. It has to do with maritime services. And then BSM, basic safety message. So your vehicles transmit information like your GPS location, your speed, your heading, etc. Again, V to I, V to V, V to X. Here's the goals. Enhance safety, improve mobility, and reduce environmental impact. So how has the U.S. and states done this? U.S. Department of Transportation did what's called the SPAT challenge. So the challenge was to state and local public sector transportation infrastructure owners and operators to deploy that DSRC, dedicated short-range communication infrastructure, with SPAT and MAP messages or broadcasts in at least one coordinated corridor within their community. Currently, there are 32 states across the United States who either have a deployment that meets the SPAT challenge or a pending deployment. So here's an example. Mr. Scott Morse, who's a colleague of mine, he and I went down to Connected Marysville back in January and met with Mr. Mike Andraco, the lead city engineer, and we successfully conducted vehicle-to-vehicle and vehicle-to-infrastructure connectivity. So here's Mike Andraco in the vehicle in front of us. This is a tablet, and then you can see all the pertinent information. You see the signal's green, we get a green indication. So that's the current phase of the traffic light. And then time remaining within that signal phase, so there's about 3 seconds of green light remaining. Recommended speed, we're going so slow that it said not applicable. We were down on 5th and Main, which is probably one of the most geographically surveyed intersections in all of Ohio, if not the United States. This little dot here represents the vehicle in front of us. So both he and our vehicle were connected via GPS. And then, of course, our own vehicle. So why? Why do we need this technology? So coincidentally, I was speaking with a University of Toledo alumni last night who worked for Ford's brake division for over 30 years. I think you're here somewhere, sir, aren't you? There you are. So I know you will appreciate this slide. So human versus computer. So if you look at the deceleration time, the time it takes to stop, those are pretty equal, those black bars. What's not equal is that reaction time. So here at 10 miles per hour, if we compare it to a computer, at 10 miles an hour, decelerating, assuming equal brake pressure, the average car length is roughly 16 feet. So at 10 miles per hour, the computer will stop your car roughly 19 feet sooner or 1 car length. Now, if you're going 90 miles per hour, you're out on the turnpike trying to keep up with the flow of traffic doing 90. The computer will stop you 168 feet or 10 and a half car lengths sooner than the human. So you can see this distance saved can equate not only to collision accident avoidance, but also fatalities, because the whole goal of this program is vision zero. Vision zero, no more traffic deaths. How are we going to get there from here? So a connected intersection. As I mentioned earlier, roadside unit. That's where roadside unit is where it all begins, which is tied into your traffic cabinet with a CV-ready processor, coming back, connected vehicle backhaul to a central traffic management system, which I'll get into here shortly. And then in vehicles are an onboard unit. And that can be either DSRC radio or cellular. Now, that cellular technology is making leaps and bounds. We were at ITS America in Detroit 2 weeks ago, and I will tell you, in every conference, they either debated or at least brought up DSRC versus cellular technology. I'll get into that briefly too. So again, there's all the basic safety message, all that includes, and broadcast every 100 milliseconds. It's very fast. Vehicle to infrastructure, and then the computing process, and then back to the vehicles. So what's the so what of that? Improved mobility, safety, system efficiency, and access. There's increased opportunities to partner with non-government groups such as private industries and universities to advance this technology. That's why we're all here today. Real-time and real-world data to help with transportation planning. What MPO out there would not want that? What city out there would not want that? So as you can see, connected intersections and connected infrastructure are very, very important to what we're doing. Here are some of the benefits. First and foremost, enhancing safety. You'll see that time and time and hear that time and time again today. A few of the safety and mobility applications at an intersection. Okay, so what? Traffic signal priority and preemption. Making sure that those emergency vehicles get through early. If they are in fact en route to an emergency. Speed management, speed curve warnings, red light violation warning. Wouldn't you like to know that somebody is about to run a red light so you don't press the gas or go pedal? And you can just stay where you're at and avoid that collision. So again, mitigating roadway conflicts. AAA. What is one of your core principles? Conflict management. Right there. Vision Zero, I already mentioned that. Improving mobility. You're increasing your operational efficiency. Lower speeds, shorter gaps, platooning. You kind of saw that in Chris's presentation with the shuttle buses, that when the two of them were operating, you saw that they maintained equal space. That's because they were connected. Roadway capacity, you're increasing that as well. Also reduced traffic congestion, and that ties down into reducing the environmental impact. Reduced pollution because of that. Smart parking availability, less searching for spaces, and in fact, fewer spaces. If you have a shuttle that's shuttling you between point A, point B, or an autonomous vehicle that goes out and takes somebody else while you're doing what you need to do, there's less spaces required. So those are a lot of the benefits with the connected infrastructure. Some of the challenges. Now, as we've already heard, these technological innovations are happening rapidly, very, very rapidly. So DSRC radios have been around for some 15 years. Cellular technology and the advent of 5G, which will be out in some say 3 to 5 years, that is the big delineator between what should we use. In my opinion, it's a hybrid solution between using the two, because there is a need or a requirement. DSRC fulfills some of those, cellular technology fulfills some of those. Privacy and security, that's also a big, big issue. You can't wish it away, bottom line, because everything needs to be secure. And in fact, with Chris and Aaron, who's gave us the demonstration at the shuttle last night, we talked exactly that, and that's the security. In fact, they cannot remotely operate the vehicle because of that. They can only maintain visibility on it. Data. There is, by collecting all those SPAT and MAP messages, there is a ton of data that is computed. So what of that? Advent of edge computing. What are you going to do with the data? Well, one, what data do you need? What are you going to do with the data? So edge computing, in order to derive the data that organizations need, and that results in analytics to make real-world changes to traffic plans based on that connected infrastructure. Low levels of connected and autonomous vehicle market saturation. So there are some 250 million vehicles in the United States. By the year 2030, they estimate that 100,000 of those will have some level of automation. Now, do not confuse automation with connectivity, because automation also includes driver assist, such as parallel parking, forward collision warning, things like that. So it will take decades to reach high levels of saturation within the market. ITS infrastructure disparity. I'll get into that here shortly with funding, because this is an expensive technology. And then connected solution for vulnerable road users, your bicyclists out there, your motorcyclists, pedestrians, maintenance workers. all of those people. What can you do now to prepare? So the good news is there's some commercially available products right now. But before you go out and snatch up that CV-ready processor, that central management system, the number one thing you need to do is identify your local needs. Identify your local needs and requirements. Then you can set some measurable performance goals and objectives, and then select the CV application, or applications, I should say, that work together to meet and achieve those goals. The traffic controllers, they also need to ensure that they're NTCIP compliant, which is a National Transportation Communications for ITS protocol. Central management system, already mentioned, RSUs, OBUs, infrastructure upgrades. So the Utah Department of Transportation, since the late 90s, every time they did a repaving project, they either installed fiber or empty conduit. So all these years later, they have 93% of the intersections connected. That is some phenomenal foresight on an individual some 2 decades ago. Toledo's making some great strides here. And there are recently fielded or deployed at Syntrax, which is an advanced transportation management system, as well as some of those CV-ready controllers. In fact, they're going to go to signal performance measures, which further helps streamline traffic and connected vehicles later this fall. Funding is an absolute challenge. There are a lot of grants out there, FAST Act grants, transit grants. There used to be a program called Tiger Grants that has recently been replaced by the BUILD, or Better Utilizing Investments to Leverage Deployment. Transportation discretionary grants, I know that's a mouthful. Connected Marysville, they actually applied for Advanced Transportation and Congestion Management Technologies Deployment Grant and received it. So later this year, all 27 of their intersections will be connected. So there's a lot of other sources out there. One of the big things, connected vehicle is a multidisciplinary engagement. You need to have a unified plan, not only with your traffic engineers, but with your legislators, etc. It takes everybody to be involved with that. And it also takes reaching out to the citizens to change the culture. As I said, market saturation with connected vehicles is going to take a while. You're going to have some holdouts, that won't do it. That goes without saying. So again, you got to reach out and change the culture. And bottom line, one of the reasons we're here today is dialogue. Talk, talk, talk. Sharing best practices. I've traveled around and met with several different metropolitan planning organizations and sharing ideas between each other. What works for some doesn't work for others. But it also sparks advocacy. So be a CAVI advocate. Advocacy, advocacy, advocacy. Before I finish today, I have some acknowledgments to make. Dr. Bill Sewell, he works with EDI. Met with him 2 weeks ago at ITS America. Extremely knowledgeable individual, and helped me tremendously build this presentation. Mr. John Ringler with Econolite, and I'll hit on him as I talk to Mr. Scott Morse. Scott Morse is a very good mentor of mine, took me under his wing in the 7 months I've been here. So Scott, thank you very much for that. John Ringler has mentored, coached, and taught both of us in all of these technologies. And I'd be remiss by not saying thank you. So thank you for that. Again, I appreciate the opportunity to speak today. Hopefully you can take something away in whatever capacity you're here, from a student to MPOs to just a general citizen. What is the so what of vehicle to infrastructure communication? Thank you.
Thank you so much, John. And our final speaker for this portion of the seminar is Mr. Jim Gee. Jim is the General Manager of the Toledo Area Regional Transit Authority, TARTA, and has served in that position since 2003. Now, he began his career at TARTA in 1992 as an intern and previously served as the authority's Director of Planning. Mr. Gee graduated from the University of Toledo with both bachelor and master's degrees specializing in transportation, planning, and urban studies. He also served there as an adjunct professor in the past and was selected as an outstanding alumnus in the College of Languages, Literature, and Social Sciences in 2012. Jim recently completed a 3-year term as the president of the Ohio Public Transit Risk Pool. He also served on the American Public Transportation Association's Legislative Committee and sits on the boards of several local nonprofit organizations, including TMACOG. He is a member of the Toledo Rotary and was a 20 Under 40 Award recipient in 2007. Jim and his wife, Kathy, have 2 children. Please join me in welcoming Jim.
Good morning, everybody. I'd like to begin with a few acknowledgments. First, I'm here supported by the Charter Board of Trustees, and we have several of them here in attendance. We have our board president, Mr. Frank Fry, representing the city of Maumee. From City of Sylvania, we have Kirk Ludwig. City of Waterville, Chuck Larkins. City of Toledo, Matt Hyaman, Harvey Savage. A board member emeritus, Shelley Pappenfuse. And I apologize if I didn't get them all with this quick scan of the room. I'd also like to thank our host and sponsors. First, AAA, who have been amazingly innovative and forward-thinking to put this series of seminars together, and kudos to them. Thank you, Edgar. And also to our host, the University of Toledo, our partner now, the University of Toledo College of Engineering, and thank you for all of that you've done. I'd also like to point out and thank Navia. We saw Chris's presentation earlier in the morning, but if you haven't had a chance, outside the door that way is the autonomous bus. And that size bus, that technology is the future of public transit, is the future of what we're going to talk about here in Toledo. And I'm really excited to have not only just a presentation, but a physical, tangible bus that we can look at and touch and evaluate. So thank you, Navia, for making sure to have that bus here. So this morning, I'm going to talk about a little bit of background information about TARTA. It's going to frankly sound like a shameless plug, but I've got a bunch of folks here, and so I'm going to talk about it. Additionally, I'm going to talk about TARTA's strategic vision, Move Toledo, and then finally wrap up and talk about autonomous buses, autonomous vehicles, and how that technology rolls into our vision for the future of public transit here in Toledo. Our organization started back in 1971, and we're currently operating in 7 member communities, the city of Toledo with 6 outlying jurisdictions. Our service is 7 days a week, 365 days a year, and we provide a number of separate distinctive services. What most folks think about when they think about TARTA is our fixed route service. And that's where a bus goes up and down a city street, stopping at marked bus stops. And we have 2,400 of those stops around the Toledo area. But we also, in addition to that, offer call-a-ride, offer tarps, offer specialty services such as Music Under the Stars, the Toledo Walleye Shuttle, and Mud Hen Shuttle, and so on. In terms of our span of service or scope of service, we provide about 12,000 passenger trips per day, or about 3 million trips per year. 60% of those trips are work trips, people going to and from work. Some of our recent accomplishments, first, we have programmed to open next year a new downtown transit hub that will eliminate the loop in downtown Toledo that was built in the early 1980s. That transit hub will have amenities for passengers, such as a coffee shop. We're working on leasing some of that space to perhaps a community health solution or a daycare solution that would fit well with passengers. And we're really excited about, because this hub will change everything that we do in downtown Toledo. In addition to that, I'm pleased to announce that Monday is the first day of our contract with the University of Toledo. And we've been working in partnership with the university for the last several months to establish this agreement, which will allow students, faculty, and staff to ride free on TARTA just by showing their student ID. So if I'm a student that lives on campus and I want to get downtown for fun, I can show my ID, take the bus downtown. Likewise, if I'm a student that still lives at home in Point Place or Maumee, I can show my ID and ride to and from campus without having to invest in the parking permit and having the vehicle. And then finally, over the last few months, we have been working on developing a strategic plan for TARTA called Move Toledo. This plan was started last November, was finished up in May, and for the development of that plan, we engaged two firms. First, Hart Associates, which was a company, which is a local company that helped us with outreach to the public. And we had focus group interviews, surveys, one-on-one. We talked to suburbanites, Toledoans, passengers, non-passengers, basically asking them what they want from public transit and what do they want to see from public transit. And we also worked with AECOM, which is a national transportation consulting firm. Ultimately, we looked at transit best practices in 58 different cities around the country and have brought those best practices back here to Toledo and included them as a part of our strategic vision. That strategic vision is on the internet. This is my last shameless plug at movetoledo.com. On that website, there's a video that outlines the process and what we're trying to do. There's the entire plan itself, a little one-page summary, and the first addendum. We released it back in May, but we've already are releasing at the end of this month the first update to that plan. And on a quarterly basis from here on out, we will continue to release updates as circumstances change here in Toledo, as the technology changes here in Toledo, and we move forward. In that plan, there are three sort of large areas of recommendations. There are core improvements, advances in technology, and new service introductions. From core improvements, we talk about going to all-electric vehicles. Coincidentally enough, there's one parked outside. We talk about restructuring the routes and redesigning TARTA essentially from a clean slate. What could public transit routing look like if it started completely from scratch? And we also talk about the change in our funding, which is really necessary for us in order to change our level of service here in Toledo. For new service options, one of the things we're looking at is a Uber type of competitor. Frankly, I believe that we can out-Uber by having drivers that are background checked, by having a vehicle that is consistent from experience to experience, by having software that now you can purchase right off the shelf that acts just like the Uber app, and by having a flat fee so you don't have peak pricing like Uber does. Our market for this is individuals and agencies both, and we see this as a real opportunity for us. We also have in that plan advances in technology. Being able to pay your fare with a smartphone, being able to better track your bus with a smartphone, and we're pleased to be able to say that in about a month we'll be announcing a new app that will help do both of those things. We also, as you can see by this picture on the screen, have in that plan a component of autonomous vehicles. This is a competitor to Navia here, but essentially it's the same type of vehicle. It's all electric. It seats about 8 to 12 folks. It is totally automated. And so, that size, that technology really is the future for us. This is our first addendum to the plan. In that plan, we had an outline of when we plan to make all of our improvements over the next 5 years. And you'll notice in red on the 0 to 2 column are test autonomous vehicles, implement all electric vehicles, and update our AVL technology. Those were in later years, and we've been able to move those up thanks to what I'm going to talk about right now. So, as we look in our Move Toledo process, and as we look at public transit in general, there's a lot of change coming. In terms of demographics, with baby boomers that are aging and having age-related disabilities, the catchphrase is the silver tsunami, but there is a lot of folks who are predisposed to using public transit just by virtue of age and disability. Likewise, on the other hand, there are younger folks, millennials and post-millennials, who are more inclined to be attracted to public transit and active transportation like walking and biking because they don't want the expense of car ownership. Those two demographic pushes together, you would think would really support improved public transit, but what we have seen is that the status quo of public transit doesn't work. That if we stay status quo as an organization and as an industry, we're not going to attract those new riders. We're going to just continue to decline, because there really is no status quo. For us, status quo is decline. What we see in the future is, with these folks, there's an expectation of technology. And we see ride-hailing apps and car service apps all merging together into mobility as service apps. And essentially, eventually, with automated vehicles, private car ownership is going to decline. The next generation of folks, they won't be interested in owning a private automobile the same as we were. The next generation won't be as interested in having an autonomous vehicle in their driveway because it's an expense. Instead, they could use a service like a Netflix for an automobile and just have the vehicle automated, come to their door, pick them up, and take them where they need to go. With those changes in society and changes in infrastructure, I think public transit is really uniquely positioned to be the provider of that service. We have the infrastructure in terms of mechanics. We have the infrastructure in terms of technology because we're already using it for our own vehicles. We have the governmental support through grants. We know the regulations. And if we're forward-thinking enough as an industry and as an organization, we could be the provider of that Netflix of passenger trips for the private user. So with that, I'm really pleased to announce that today we can say that we have a $1.8 million grant that will fund the testing of an autonomous bus technology here in Toledo. These are funds that are available starting next year, and I really want to thank our partners, especially TMCOG. Dave Gideon sitting in the audience. Dave, thank you, because without the support of TMCOG, who's our Toledo Metropolitan Area Council on Governments, we wouldn't be able to announce this grant. We have a lot of details to work out. In terms of the project itself, we're obviously going to have to bid it out to companies like Navia and Ali and so on. We're going to look for partners to help us make sure we're successful, like the University of Toledo, like Drive Ohio. We need to figure out the fares. If this is a special route, maybe we can find partners to help subsidize that fare. And of course, we need to look at the routing. Our preference is to have a route in downtown Toledo that connects the attractions that we have now. But we're going to have input, not only from the community itself, but also from the vehicle manufacturer in terms of what routing and what infrastructure needs that vehicle will have in terms of charging, in terms of route characteristics, and so on. So a lot of details to work out, but in a nutshell, it's here. It's tangible. The bus is outside, or a representative bus is outside. The grant is in hand, and we expect to roll this out next year. This routing here, simply a draft, connects the Uptown District with downtown Toledo over to the Meadow Grounds Metro Park. We expect to tie it in at one of our 2 downtown facilities because we'll need a place to relieve drivers. We will need a place to charge the vehicle, as it will be all electric. But very exciting for us to be able to be a part of what will be the future of public transit in our country. So with that, thank you, AAA. Thank you, University of Toledo. And thank you all for your attention.
Thank you so much to Jim. What an exciting announcement. We're now going to take about a 5-minute break to set the stage for our panelists. At this time, please remember to submit any questions you may have holding up your card, and someone will come around and get it. You can also bring it right up to the basket in the front. So we'll be right back.
All right, it's on now. We'll get started here in just a minute, so if you wouldn't mind taking your seats. If anybody has any more cards that we haven't collected, bring them on up, right up front. We'll get those read.
Welcome back, everyone, and I'd like to introduce our panelists who will be part of the Q&A part of this program. Our panelists today, in addition, have already met, are made up of UT faculty whose research involves different aspects of the autonomous vehicle world. First, I'd like to introduce Dr. Eddie Chu, professor of Civil and Environmental Engineering here at the University of Toledo and director of the Transportation Systems Research Lab. He has nearly 30 years of experience as a researcher in the transportation engineering field. His research interests include transportation assessment, asset management, smart transportation systems, and applications of analytical tools, including traffic simulation, optimization, and artificial intelligence to solve transportation problems. Dr. Chu has conducted more than $7 million worth of externally funded research as a principal investigator of more than 40 research projects. Also like to introduce Dr. Buyan Alam. He's an associate professor in the Department of Geography and Planning here at the University of Toledo. He received his PhD in urban and regional planning from Florida State University. He also has master's degrees in civil engineering and in regional and rural development planning, and a BS in civil engineering. His major research interests are in public transportation, accessibility, and mobility analysis, smart city and transportation in legacy cities, traffic safety, travel behavior analysis, and demand modeling, relationships between built environment, land use, transport, and health, application of planning techniques in transportation planning, and resiliency of transport systems to climate change impacts. Please join me in welcoming this impressive group of panelists today. I also wanted, oh, goodness, did I, system going? Okay. I also want to take just 1 minute here because a lot of the people who work very hard to make this happen, you all don't meet. So I would like to take a moment, probably won't stand up, you're one of them, Diana, but there are a lot of people who work very hard behind the scenes to make these incredible events happen. I think they often don't get the credit or the thanks they deserve. So please, everyone who is involved in making this happen, Diana, and there are a lot of others here, please stand up and let's thank them properly. We're going to start with, are there plans to have autonomous vehicles communicate with pedestrian cell phones?
I guess I can answer that question. So Great question. In terms of autonomous vehicles, yes, they will be communicating with cell phones, not necessarily speaking to them, but you'll be able to use an app like you would on your phone today to summon a vehicle to your stop or to let the vehicle know that you need to get out. As I mentioned before, you'll be able to stream content into autonomous vehicles, whether it's your music. You may be able to stream through a screen, even a movie you're watching at home. So imagine you're at home, you need to leave, you're watching a movie. It's a great, one of those Marvel movies that seem to come out every week. And you don't want to, you have to stop it, and then all of a sudden you get into this autonomous vehicle. You could then go ahead and stream that movie as it was playing for you in your vehicle as well. So there's going to be a lot of content ability to go from home to the vehicle, and it'll be really, some point in time in the future, a seamless experience for you.
I'd like to add on to that, and some of that technology actually already exists. There's a manufacturer that we represent that is cell-based, and I just opened the app on my phone, and this right here is how I get information from those vehicles. So it will, if the vehicle has the same app, this is transmitting my position as a pedestrian, and then the vehicle is transmitting via the infrastructure to my phone that it is coming. And in fact, some of the research we're doing with Ohio State is we're in the initial stages and planning of working with their school for the blind. And the same company that develops this app is working with us to ensure that as a blind pedestrian comes up to the intersection, they're getting audible tones on their phone that a vehicle's approaching. So yes, that technology absolutely exists, and very good question from whoever asked that.
Of course, I think this is the question that you all probably hear most. What are the risks of an autonomous vehicle, whether it's a taxi, a semi, a personal vehicle? And what will the cost be, of such a vehicle in the future? These are two totally separate questions.
I can answer, well, I guess I can start with the safety side. So from an autonomous vehicle standpoint, we at Navia obviously take safety as really one of our core missions. And so when we're looking to design technology, we go through a lot of redundancies, testing, both simulations as well as real life testing before we actually will launch either a new vehicle, whether it's a cab or a shuttle, or an enhancement to our current technology. We also work very closely with regulatory bodies, whether it's state or local or federal, to ensure that our vehicles are complying with the current and future regulations that will, of course, happen for these technologies, either in the U.S. or Canada or outside of North America. In terms of cost, I'm happy to talk about that, but probably not something I'll throw out here right now.
Well, and there are a number of different tiers to that cost question, probably. How much does it cost to get in one of these vehicles? How much does it cost to take a ride in one of these vehicles? Will the cost go up of a ride on TARTA because of the technology? I think that's probably
Sure. So I could just add, so right now all of our shuttles operate around the world for free. So usage is free. At the University of Michigan's campus, the use of the shuttle is part of their existing transportation network. So you just have to show a student ID. You're able to get on the shuttle for free. We do anticipate, though, in the future that there will be a paid model. How that's created, I think there's going to be a variety of different models where you may have content in the vehicle that could reduce the cost of using that vehicle. You could have a payment system or token system that is fully integrated into a phone that you swipe when you get into the vehicle. So there's going to be a lot of different business models and payment plans for this type of technology.
From TARTA's perspective, we see these technologies as allowing us to save money. Obviously a safer vehicle means less accidents, less safety concerns. All electric typically means less maintenance costs. These technologies ultimately help us to save money and not add cost.
important point. Certainly size difference as well. If you look at the very large buses that are on the road today versus they'll be in defined areas, I assume, the new technology.
Yeah, so you'll see, if you've been following this industry, you're seeing very small vehicles that are literally autonomous vehicles, and all they do is carry packages. And so you'll see vehicles like that operate on sidewalks. You'll see 2-seat vehicles, 4-seat vehicles, 6, 8. They'll come in a variety of different sizes, all with different use cases. it will be increasingly important from a city standpoint and federal and state standpoint to determine right-of-ways, access, where can these vehicles operate, when can they operate. So you can imagine you've got all sorts of different types of construction sizes coming forward.
How much investment is needed into our nation's public transportation systems? And does the federal government have a plan for making this investment?
Lots and no. I don't remember the multi-hundred or multi-tens of billion-dollar investment that currently we're behind in terms of infrastructure. It's not just public transit, it's roads, it's bridges, it's basically every facet of our infrastructure is just historically underfunded. The federal government funding piece comes from a gasoline tax that has not been changed since the early 90s, is not adjusted for inflation, and as you can imagine, the buying power, especially as we move towards more fuel-efficient vehicles, just continues to decrease.
Can I just for a moment go back to the previous question? Cost, a major cost for public transportation is for the drivers' salaries and their benefits and those type of things. So I believe the new technologies will save money from that perspective. Now, what those drivers will do in future, what professions they will take, that is different, socio-economic aspect of analysis, that is different thing. But technologies will help save money for the public transportation agencies. Right, Jim?
Are there
Real quick,
partner-
Lisa.
Oh,
On the infrastructure, bottom line, yes, you could come up with a quantifiable number. Take the number of intersections across the United States, how much it would cost to, let's say, employ a DSRC radio, dedicated short-range communication radio, and you could come up with a quantifiable figure if that is your definition of a smart intersection. But as I believe Chris or Jim, one of you said that the amount is in the billions and billions and billions of dollars. So yes, it is very, very expensive.
Are there partnerships in place or in the works with Honda, General Motors, Jeep, Ford?
Yeah, so in terms of partnerships, obviously we have partners right now that we publicly announced. Obviously go to our website, navia.tech, and check out who our partners are. And we are constantly talking with other companies, whether it's other automotive OEMs, to engineering service firms, to transit agencies. Navia certainly looks to partner with everybody in this space.
And a lot of the major car manufacturers are going via DSRC radios. Now, unfortunately, a lot of them are the high-end manufacturers. You're talking your Cadillacs, your Teslas. Audi recently made an announcement that they were investing in DSRC technologies for Europe, not the United States. Now, hopefully, a natural transgression would be over to the United States as well. So, the short answer is yes, there are several. However, they're typically the high-end manufacturers currently.
Of course, everything does trickle down if you're old enough to remember, like I am, when heated seats and computers were just absolutely revolutionary in vehicles and very high-end, and now they're in everything. So that, I assume, would happen with this technology as well as we move forward?
Yeah, no, absolutely. As you see with anything related to AV, what you'll start to see is as the cost model starts to reduce, whether it's the battery cost, which is a big portion of the cost of the vehicle, to the camera-based systems, the LiDAR systems, as those costs start to drop, one, you'll see more of them, so that'll increase the accuracy and safety of the vehicles. That'll happen. And then two, the actual technology will get better, so you'll be able to then operate at farther speeds, faster speeds, more inclement weather, and so the technology itself will just get better. And then you'll start to see the interior of the vehicle start to change too, as people move from more of a transit system like our shuttle is, to more of a 6-passenger or a 2-passenger. You'll start to see the interior of those vehicles start to actually change as well, and become much more like a living room type of experience as opposed to a traditional vehicle experience.
Will the autonomous buses and cabs be wheelchair accessible?
So that's a really important and great question. So that's something we are dedicated to and working on today, to produce our shuttles and cabs to have the ability for a fully ADA compliant ramp for those who are that need. So Don't have a date yet, but we're looking for 2018 for the deployment of that type of technology inside of our shuttles. So it's something we're certainly working on.
Whatever we deploy with the Tartar name on it will be wheelchair accessible. Absolutely, it has to be.
We all know some plausible security concerns. Do you think a future attack, like in the movie Fast and Furious, is possible? Could hackers take control of all smart cars and use them to attack a foreign delegation, a convoy, anything like that?
So I haven't seen that Fast and Furious. I'm not sure which one that was in. Was that 7 or?
8.
Oh, that's an 8?
believe,
Okay,
yes.
I don't think I saw 8. Yeah, I'm not sure which one that one is. I'll have to look at that. That sounds pretty cool. So no, for our shuttles, there wouldn't be any fast or furious. It would be slow and slow. Maybe not even furious. So one of the things that we do is we make sure that from a safety cybersecurity standpoint, you actually can't hack into our shuttles remotely. So if you're thinking you can get out there with a laptop and all of a sudden that vehicle's moving around, you can try it. I'd love for you to try it, but unfortunately nothing would happen. So you actually have to physically put a USB port inside of it, and then you can operate the shuttle. So partly it's just from a security standpoint. We want to ensure that things like Fast and Furious don't actually happen. That's for us, that's for Navia. Others are obviously taking potentially a different tact and different way of looking at cybersecurity. Some are allowing for the remote operation of their vehicles. They, of course, will have their own security protections in place, and I can't comment on those, but from our perspective, not having the ability to remotely access the shuttle adds an additional layer of protection. And I will have to check that movie out.
Are the shuttles, or this kind of autonomous vehicle, coming to the University of Toledo anytime soon?
Maybe. We have a great partnership with the University of Toledo with their transit system. This is a very logical market for an autonomous shuttle, the campus shuttle, on-campus service, along with the service between campuses. So it's a really logical place to have it here. As we grow the technology and I guess grow the service, that's certainly something that we want to consider.
Yeah, I'll just add, from our perspective, looking at the shuttle outside, the use case for the AV shuttles for campus environments are really strong. We have a shuttle that was deployed starting in June in the University of Michigan, their North Campus, so I know that's not too far away from here, so if you get a chance, drive over, hop on the shuttle, it's free, and we'll have a shuttle actually operating out of University of Nebraska's campus starting on Monday. Again, the use cases for shuttle technology on college campuses are very strong, whether it's first and last mile transportation needs, filling in niche transportation nodes where putting in large corrugated buses or light rail systems probably just doesn't make sense. To the research component to it, where allowing for universities to do research, create a curriculum around this type of technology. So being able to touch and feel and test is a really important piece for them. And 3, of course, because they're fully electric, you really start to embrace, obviously, the low carbon footprint standpoint as well.
A design question here. Why did you choose the symmetrical shape for the autonomous shuttle?
Great question. That actually predates my role here at Navia. I joined last summer, so not sure. I think it actually looks kind of cute. It's kind of like an armadillo without a tail. There's no front, there's no back. Others, as you saw before with Jim's presentation, shows a little bit more of a boxy look. Would love any design criteria. If you can send us a picture of a design that you think looks better, happy to see it. So.
2 questions here that are in the similar vein. Are the autonomous vehicles able to compensate for inattentive, reckless, or horrible drivers that it may encounter? And how are people in cars going to get along with these autonomous vehicles?
So today we have, when we operate somewhere around 68 shuttles around the world, both in light and mixed and heavy traffic. And so today what we do is, whether it's in a pedestrian area like in La Defense in the financial heart of Paris, or in downtown city of Las Vegas, our shuttles are constantly monitoring and measuring not only for revelers and people who've been partying in Las Vegas and they want to walk in front of the shuttle, to distracted drivers. We certainly have a very long-range sensor systems that are constantly monitoring, tracking people, bicyclers, cars, you name it, whatever's coming at it. And so obviously for the shuttle here, the speed that it operates on, our time of air is certainly better than, say, a vehicle that's operating at 40, 50, 60 miles an hour. And so today we feel very confident in the technology and the safety aspects of it. We're always constantly working on improvements to that technology, so it's nothing that's static. One thing to mention for our vehicles around the world is if you can imagine they're operating, they're also gathering a tremendous amount of data. That data is being sent, whether it's in Las Vegas, the University of Michigan, Paris, Lyon, wherever, all getting sent back to a central system where we analyze and crunch that data and then go ahead and send out updates. And that update could be, how do you deal with light snow? How do you deal with inclement weather, rain, whatever that is? And if there's vehicles that are going to be seeing or being in environments that would allow for that type of scenarios, those vehicles will receive those updates. And so we're constantly improving the technology on these vehicles on a daily, and weekly, and monthly basis.
And I know from a manufacturing standpoint, both Tesla and GM, they're autopilot, for lack of a better term, which is basically automated or enhanced cruise control, which also has lane keeping. They have both audio and visual. So I know Tesla's threshold is 1 minute. If you don't touch the steering wheel for 1 minute, you'll get visual indications and also vibrations as well to take the wheel.
Good that you brought up Tesla because they are part of this next question from an 11th grade student. With companies like Tesla that are both an electric car company and making strides in autonomous technologies, is it possible for this autonomous technology that Pathmaster and Navia are working on to be brought out by them, or would that be a potential competitor to Tesla and other such companies?
So great question. So Tesla, they look at more of a consumer market. They're developing vehicles that anyone here in the audience could buy, could have at their home. Our vehicles are much more for the business-to-business market. So we're looking for transit agencies like TARTA, universities like University of Toledo. They would be looking to purchase vehicles or whether it's the cab or the shuttle. So we actually would not sell our vehicles to a consumer, whereas a Tesla would be obviously selling vehicles to consumers. And I will leave it over to John for that other portion.
Our focus is on the infrastructure side of the house. Do we have some solutions to vehicles? Yes, absolutely we do. But the preponderance of them have to deal with the infrastructure and not the vehicle itself. Don't get me wrong, we're not in the autonomous vehicle industry per se. However, we have a foot in the door, if you will, because we're an advocate for that technology. Because it transcends not only the vehicle, but also the infrastructure, because it's a holistic solution. And we all need to be part of that.
The media seems more interested in focusing on the automated vehicle mishaps instead of the progress, which scares a lot of people. How do we fix that?
So from my standpoint, a lot of it is what we're doing here. So it's education. It's getting people to come out and feel and touch and at some point, obviously jump on one of these shuttles and cabs and be exposed to it. So I think it's always easy to point out why something doesn't work, but it's harder to show why something is working well. With further deployments, further adoption of the technology, the concerns that people will see and feel will start to abate. Obviously, every time there's an accident, someone gets injured or worse. That's an input on the industry, but like any other technology change, whether it was the advent of the automobile over 100 years ago, the advent of flying, there's certainly going to be those initial risks. It's up to obviously companies like ourselves to minimize those as much as possible and work with regulatory bodies, whether it's state or local or federal, to ensure that the laws and regulatory schemes are in place to allow for the technology to flourish, but also to keep safety as a paramount issue for us.
This is nothing against our fantastic MC and the industry she represents, but sensationalism sells. When it comes to market share, the sensationalism or, unfortunately, those accidents, they get put front and center, unlike the technological advancements.
What if you lose communication with the roadside unit? What will happen in the case if there's a software bug?
So our shuttles are actually designed to allow for them to operate on one or up to 4 systems. So we have a LiDAR system, which we talked about earlier, which is really that light-based radar system. So what we do is we map the route initially, and then that LiDAR system then is constantly sending out something like 10,000 signals a second to kind of sense the road. We also have a GPS or GNS system which triangulates the shuttle to where it's supposed to be, up to 1 square meter or 1 square inch. And then we also have an odometry system inside the wheelbase that actually measures the distance the vehicle's traveled. And then we have some camera-based systems that can visualize the route as well. Any one of those systems can actually allow for the vehicle to operate. So if for whatever reason the LiDAR system were to go down, the other 3 systems could allow for the vehicle to safely operate. 2 go down, the same thing. Obviously, if their systems are going down, and all 4, for whatever reason, go down, today there's obviously an antenna on the vehicle. The vehicle can be pulled over safely, the doors opened, and everyone can get out.
In the areas that Navia is operating, has all of the infrastructure been upgraded? Does the taxi model have the capability to understand traffic signals outside of defined areas with the infrastructure upgrades?
So one of the things that our technology has, which is a little bit different than others, is we actually don't require any infrastructure developments or deployments. Obviously, if you're dealing with traffic lights, you would have to have some sort of a DSRC system that would allow for that traffic light system to communicate with our vehicles. But there's no lines being painted or signs being put into the infrastructure for our vehicles to operate, which is a little bit different than what you're seeing from other type technologies. So when we're looking at deploying our vehicles today, our shuttle can operate about a 2.5-mile predetermined route. Our taxi cabs will be able to operate within a 5-mile geofenced area. I would say every 6 months, every year, that length of operation will continue to expand as processing power and software costs start to decrease and the capacity to hold data will start to increase. You'll see those distances start to go from 2.5 miles for the shuttle to say 3.5 miles to 5, and the geofenced area from 5-mile area to maybe 7 to 10. Again, all really having to do with processing power costs.
Comparing autonomous vehicles and infrastructure is kind of like, I don't want to say apples and oranges because they're both fruits, but an autonomous vehicle can operate without talking to the infrastructure because it knows its surroundings. But at the same time, there has to be some upgrades in infrastructure, and I'm talking like line painting, signage, things like that. Did not stress that point in the presentation, but autonomous vehicles are reliant a lot of times on those markings. So as this technology advances, we're finding that we have to go out and repaint stripes on roadways, make them wider, make them more visible so those cameras on the autonomous vehicles can actually see them. Bots dots. Everybody knows what bots dots are? You know, they're those probably 4x4 or 6x6 things that go between the lines. If you run over them, those and autonomous vehicles do not get together or get along very well. So a lot of the transportation industry is finding that they need to remove the bots dots from the highways for the autonomous vehicles. So again, it's hard to compare the two, but you have to compare the two because they're synonymous.
A lot of jobs could potentially be eliminated because of automated vehicles. Do you think there's a way that this technology may create some jobs as well? And what about jobs for people who are not trained technicians, like the truck drivers and the taxi drivers?
Yeah, so great question. So from our perspective, obviously, during this initial rollout of the technology, there are regulations that really mandate for someone to be on the vehicle at all times, so an attendant or an operator. We perceive that when that regulation does change, that those jobs that are currently being used for driving vehicles, whether it's in the campus or short haul or even long haul, the jobs will obviously evolve, and so you'll have maybe somebody, a technician in the vehicle that's doing diagnostics checks, maybe doing work on the vehicle. They're able to be in the vehicle. They're not per se driving the vehicle, similar to what an airline pilot does today, right? The airline pilot has really 2 roles, to take off and to land, but most of the time they're sitting in the vehicle. They're really doing something else while the plane's flying, and so you'll see that evolution. You'll also see, just like in the mobile phone industry, other industries being created around this type of technology. And so you'll start to see other businesses and industries spring up from it, whether it's repair, maintenance type industries coming up. You'll see different business models. So I had discussions with a startup company in Silicon Valley, and they're looking to outfit our shuttles with mobile refrigeration pieces. And so you would actually have a mobile grocery store. And so instead of having you go to the grocery store would come to you, you'd use your phone, you swipe it, the doors would open, and you could grab fruits, vegetables, yogurts, you name it. So it's that type of innovation that I think we're not even thinking about because it just seems so far out, but other folks are thinking about that you'll start to see, and those jobs, again, will really start to evolve and move from, driving behind a wheel, which I personally don't like, to maybe doing something else, but still involved within that industry, but in a slightly different manner.
Imagine thousands of cars going to downtown to drop everyone off to work. And once everyone gets out of those cars, where do the cars go? Do they park? Do they go back home? Both scenarios will again have issues. Obviously you're talking about space in the downtown and fuel, energy, and, efficiency and all of that.
I think today's presentation by all three presenters tied together. I think this is where the public transportation comes in. We just cannot all drive our own cars, whether it's autonomous or our own conventional cars. It's when the congestion happens, everybody going the same direction. So I consider public transit or transportation as a share ride. Basically, it's a share ride. So I was very glad to hear Mr. G talk about TARTA is looking very progressively to the future, right, to compete with Uber of the world. And because buses and future buses basically is a share ride. And when they get there, it's autonomous, so they can dispatch themselves to pick up the next batch of passengers on board. So the whole thing is, the transportation in the future is sort of holistic in the sense that trying to find a solution that address different people's needs together. And it's not one solution. So a lot of the companies right now are just racing to put the first autonomous vehicles in business operations and try to monetize it, or at least demonstrate that they have the capability and demonstrate the skill. So there's a different technology. I believe Navia's technology and Waymo's technology, they are all somewhat different. They're very different. So there's going to be mishaps going on once in a while. The Tesla's technology is different. And eventually, the good things about the computer science and artificial intelligence is once they learn this mistake, they probably won't make that mistake ever again. Unlike human beings, that we make mistakes all the time. So that allows technology to merge into some of the superior ones will surface to the top in the next few years, hopefully. And the other aspect I like to mention is the infrastructure side. I think it's very important because the DSRC, the Dedicated Short Range Communication standard, has been there for 15 years, as John mentioned. During that period, the cellular technology has moved from 1G to 4G, and we're going to see 5G probably in the next 2-3 years. So the private sectors are moving much faster than the public sector. And the reason is the public sector, we don't have the investment that we need, that Mr. G mentioned, right, John? Jim mentioned that we need an investment that takes sort of a public sector's commitment to make that investment and to make the signal smarter. So we need to find some sort of private-public partnership so that the private sector also invests on the signal side, not just the public sector, because gasoline tax is definitely going down because we're going to see more and more vehicles be electrical vehicles, and they're not paying the gasoline tax. And so therefore, the funding for public sector investment in transportation is something that needs to be think about. Even though the private sector right now, the startups, they're just trying to figure out ways to surround the autonomous vehicle technology with new ideas, right, to monetize those ideas. But I think as an overall solution, the government sector needs to be involved to encourage the public-private sector investment into the infrastructure side.
As Dr. Chow mentioned, if with all these autonomous vehicles and autonomous public transit vehicles, they come downtown, they drop folks off, they're going to go on to their next trip. But, especially with downtowns and morning and evening peaks, you'll have excess autonomous vehicles. Most of them will go on to another trip, but some of them won't because that trip won't be there. What'll happen is they will go and be stored somewhere, but it shouldn't be in a downtown parking facility or a downtown parking lot because that real estate is way too expensive to be dedicated for parking. And so you'll see infill in downtown areas, a reduction in parking, but what you also will see is more space needed for queuing people and queuing vehicles. Because if you have all these people hailing autonomous vehicles, they're coming out of the workplace, there's going to have to be some area for them to board their autonomous vehicles. So there'll be more space for queuing, but a lot less space for parking because essentially the car will park itself in a spot that's a lot less expensive than a downtown parking garage.
Let me add one short thing is when you have thousands of vehicles going in the same direction, that's where the rail transit comes in. In Toledo and cities like us, the public transit is bus basis. So the bus system, particularly I think Jim can correct me, the ridership is going down for the bus riders because it's just not as convenient and so on. Because bus doesn't get the dedicated right of way. And they're competing with other cars, even though there are some cities, they have the high occupancy vehicle lanes and so on. But bus doesn't have the kind of speed that can compete with the rail transit, right? It can be there, and it's less convenient compared with the point-to-point, like taxis or other transportation. So one way to address that is tie that into infrastructure. We need to encourage people to take the bus and allowing the bus to drive faster on a dedicated lane and get the priority in terms of signals. So that happens in many cities already, so that the bus becomes actually faster than driving your own cars or taking a ride-hailing service and other transportation mode. That makes it more incentivize people to take the bus, and that will actually, and the bus actually, particularly the Navia type of bus, can serve as the first mile, last mile solution. So it's actually connect people to a fast moving and a high capacity. One fact is one rail transit line can take away about 10 highway lanes. So in terms of capacity, you do have that kind of a demand, then you would consider a transit service that it's dedicated, much faster, much higher capacity.
I'd like to just re-emphasize what Dr. Chow mentioned and Jim Key mentioned, that because of electric vehicles, federal government, state governments are going to get less tax money. And local governments, like cities, they are going to get less money from parking. Managed by the cities. Now they have to come and work together with the private companies. So PPP, public-private partnership. I think they have to, coordinate with the private organizations. Otherwise, how are they going to solve the money that they are going to lose?
I just make another comment in terms of also when you think about that type of 10, 15-year distance in terms of everyone jumping in hundreds or thousands of AVs. As you can imagine, when you're driving today, you can't talk on your phone that well, or you're not supposed to, you can't text, can't be on your computer, so you're going to have a lot more productivity by sitting in one of these vehicles as you're going to work. And so what's going to happen is you'll start to see people who will say, well, traffic may not get better initially, but I can still do more work. And that allow people to either leave later or go earlier, knowing that they can go ahead and do their work during the days. Two, I think in terms of what these shuttles do or these cabs do when they're not taking passengers, I think you'll also see a high integration for companies that are looking to ship products. So you have delivery systems. You may have a consumer in the morning, consumer in the evening, but during the day you may have vehicles that are actually delivering goods and products within a city. So they may be delivering flowers or delivering groceries or whatever those vehicles are doing. They're doing something else. My guess is they won't be sitting in the garage idle very much because it's a very expensive fixed asset, and you don't want that vehicle sitting unless it's charging. You want that vehicle being used. So I wouldn't anticipate that these vehicles are going to go sit in the garage, whether it's in the city or not, as Jim mentioned. These vehicles are going to be used as much as possible, even using electric roadbeds, so they'll actually be charging while they're driving and operating. So these vehicles may be operating 10, 15, 20 hours a day, and because you don't have a driver, you don't have to worry about those issues as well. So I think it's going to be a real change, and I think cities around the country will have to, from a revenue standpoint, think about how do they meet those challenges when they're not getting revenue from parking, when they're not getting revenue from gasoline tax. There will have to be another mechanism put in place, some sort of a fee system that may have to come into play to make up for some of those lost wages, although there will be certainly a lot of productivity gains.
Last question. Could any of these autonomous vehicles be fueled by solar energy?
So the short answer is yes. You certainly could look at either using solar to power the vehicle off. So you have a solar panel farm, that electricity is then being used to charge a shuttle. You could look at putting solar panels on a vehicle. I don't know from our size whether it makes sense to put a solar panel on the sides of our vehicle, but obviously that type of development is certainly going to happen. You could even see, as I just mentioned before, electric roadbeds where the vehicle is actually charging as it's driving, and that could certainly be powered by solar as well.
A lot of fantastic questions. Well, we have 2 minutes, so I have this last one, and if you didn't have your question answered, I'm sure the panelists will be happy to speak with you afterwards, but what will the traffic speeds be for these various vehicles? And obviously that's going to be very different depending on the vehicle.
Yeah, so traditionally when you look at a downtown area like a downtown Toledo during peak driving time, most of the time people are driving 8, 10, 12 miles an hour. And so it's very slow. Obviously, off-peak times, you're driving probably closer to the speed limit. So I think it all depends on what you're going to see. You'll see cities like London and large urban areas that are actually starting to ban vehicles from their downtown areas. They may lift some of those bans, especially if they're talking about AV technology, where maybe it's limited to mass transit type vehicles that are bringing folks in. That makes more sense. I just think it's too early yet to tell exactly how that's going to play out, but it's going to be certainly exciting.
Well, thank you very much. All just very informative and a lot to learn as we move forward here. Going to be a lot of shifts in this. So really, as I said, an incredible opportunity for all of us to have all of you sitting here and be able to learn an awful lot as we move forward. At this time, it is my pleasure to introduce AAA Senior Executive Vice President, Edgar Avila.
Good morning, everyone. On behalf of AAA and the University of Toledo, we want to thank the speakers and panelists for their presentations and panel discussion, and of course, to the moderator, Lisa Guyton. So thank you. And thank you to our audience for attending the Technology Takes the Wheel speaker series. The speaker series has shown that autonomous vehicle technology has the potential to offer significant benefits to society when fully deployed. As a result, many cities and states have begun planning to modernize their highways and streets for self-driving vehicles and creating a smart city environment for the benefit of motorists and pedestrians. Columbus, Ohio is well underway, having won the Smart City Challenge against 78 cities to develop comprehensive plans to make their cities smarter. The American Planning Association reported Columbus has more than a dozen projects, starting with a vehicle connectivity system, smart street lighting, and a pedestrian collision avoidance system for transit vehicles. But that is not all. Next are plans to move on to implementing a common payment system and planning for multimodal trips. And it also plans to link patient scheduling at a hospital with a transit schedule in an effort to reduce infant mortality by encouraging prenatal health care visits for expectant mothers who lack access to reliable transportation. So you can see autonomous vehicle technology will enter and benefit many facets of our daily lives. And past history shows technology and innovation occurs quickly in the marketplace. In many cities, government, community, and business leaders are forming steering committees to plan and implement a smart city initiative to prepare for the coming deployment of self-driving vehicles. So act we must to ensure the safety of motorists, pedestrians, motorcyclists, bicyclists, and all communities. It is with this goal in mind that AAA, the University of Toledo, and TARDA have requested the Toledo Metropolitan Area Council of Governments, or TMCOG, to consider serving as the sponsoring agency to establish a Smart Toledo Coalition Steering Committee. This is a critical first step for our community and one that we fully support. After the seminar, we've made arrangements to transport the Navia shuttle bus to the downtown riverfront for general public viewing this afternoon and early evening. While you are downtown, please see the Navia bus, and you can also participate in the T-Town Dash Scavenger Hunt, sponsored by the Toledo Regional Chamber of Commerce, or the Art Loop Art of the Automobile event sponsored by the Arts Commission. So thank you again for attending, and please, if you have not seen the Navia bus, please stop by and see it on your way out. Thank you.
And I would like to give a heartfelt thank you to our speakers and panelists and all of the people who helped make this happen here at the College of Engineering this morning. Thank you to our co-sponsors of this series, the University of Toledo College of Engineering and AAA of Northwest Ohio. I truly believe that this series can help us to ensure that Northwest Ohio is ready for the changes that are coming our way and make sure that we are leading the way in innovation and preparation. And as you just heard, we are going to be doing just that. Please note on your calendars that the next seminar in this series will be September 21st. Those of you who registered for CPD certificates, those will be emailed to the address that you provided. And once again, thank you everyone for being here.